this time we'll be dealing with higher degree inequalities or inequalities of polynomials that involves degree of 2 or more. Let's start with this first item. Okay, so for this first item, take note that in dealing with inequalities, the first thing that you will do is that isolate everything to one side, which we already have here. Next is to factor everything that you have isolated, which means that we need to factor this one out. Fortunately for us, this one is just a perfect square trinomial. Indeed, take note that this thing is the same as x squared plus 2 times x times 1 plus 1 squared. So just recall that when you have that form, by perfect square trinomial, this thing just factors into x plus 1 squared less than 0. And then what do we have here? Take note that since we have a square out here, any real value plugged in out here plus 1 would still yield a value that is greater than or equal to 0, since that's how squares work. But our goal is to find the solution set or values of x that would give this to be less than 0 or negative. Clearly, that would be impossible since this one on the left is always positive or 0, which means that for this one, we actually don't have a solution. Let's move on to the second one. Okay, so for this next one, again, move everything to one side. So basically, we move this to the other. So to do that, what we'll do is we will add 1 both sides. So that will give us 4x squared plus 4x plus 1 greater than 0. So like in the first one, take note that this one is actually a perfect square trinomial again. So I won't break it down like in the first one, but you'll still get the same idea. So by perfect square trinomial, this one factors into 2x plus 1 squared greater than 0. From here, observe here that this thing here, it has a square again. So any real value that we plug in out here will be non-negative, or that is greater than or equal to 0. But since our goal is just greater than out here, basically what we do is we just omit the value wherein this thing will be equal to 0. Essentially, that just means that the solution set for this one is the whole real numbers except a certain value, or that value that would make it 0. So scratch out here. So if we equate 2x plus 1 to 0, so basically we move 1 to the other side, so that will be negative 1, and then divide 2. That will give you x to be equal to negative 1/2. So this means that the solution set for this one is all real numbers except the part wherein it will be equal to negative 1/2. So let's first fix this one. Or in interval notation, x in negative infinity up until negative 1/2 union negative 1/2 to positive infinity. So the answer for this problem will be either of these two. Let's move on to the third item. So for this third item, so again, move everything to one side, then factor out. But to minimize a step, let's first take note that this thing out here factors into x times x squared plus 1. So you'll see later why I did that, but a hint there would be this one is x squared plus 1 and this one is x squared plus 1. So that would play a role later on. So let's do the trick again. Let's move this first to the other side. Technically, we will be subtracting x squared plus 1, quantity x squared plus 1 both sides. And that will give us x times x squared plus 1 minus quantity x squared plus 1. And this will be greater than or equal to 0. Okay, so from here, observe that we can actually factor out this quantity outside of the expression. So that's the reason why I did those factoring stuff. So observe that if we factor out x squared plus 1 out here, we'll be left with x minus 1. And this one is greater than or equal to 0. So what we did there was factor. And then from here, take note that for this first factor, since we have a square out here, that means that for any real value of x, this thing will be positive. Add 1 and the result will still be a positive number. In fact, it is strictly positive due to plus 1. So what I mean by that is, we can just view this like a positive constant that we multiply to x minus 1. What I mean by that is, we can just treat the problem of finding just x minus 1 greater than or equal to 0. Let me put an exclamation point out here. Since these two are technically not the same inequality, but they give the same result or they give the same solution set. Then solving for this inequality, let's just add 1 both sides, or basically move this one to the other side. So we'll have here x to be greater than or equal to, or in interval notation, this is basically x in the interval 1 to positive infinity. Take note that we use a closed bracket out here since we're dealing with equal to out here. And this one is the answer for the problem. Let's deal with the last item. Okay, so for this last item, do the same trick. Isolate everything to one side. So let's move this to the other side. What we'll be doing is we'll be subtracting 2x both sides and add 3 both sides. So that will give us x squared minus 4x plus 3 less than or equal to 0. And then again, let's just factor. So I will be relying on your factoring skills out here. This just factors into x minus 1 times x minus 3 less than or equal to 0. Okay, now so for this types of inequality wherein we'll obtain 2 different factors, we'll be needing a table of values. So let me first set up the table of values before I explain it. Let's explain how this works. So first on this left side, basically we have the individual factors x minus 1 from here and x minus 3 from here. Then at the bottom we have their product, or basically this one out here. And then for the part out here, this one is determined by the parts we're in. These things will be equal to 0. Like for instance, when you equate x minus 1 to 0, you'll basically obtain x equal to 1. We divide it at the point x equals 1, and then for x minus 3, we divide it at the point x equal to 3. You can treat this one as the intervals. To fill in this, again, this is called a table of signs. So essentially, we'll be filling up these parts out here with either positive or negative. So one trick that you can do here is just check each interval, choose a test value, and then plug it in out here to determine the corresponding signs. But that would be inefficient. What we do instead here is we first mark the points wherein these things will be equal to 0. X minus 1 will be 0 at the point x equals 1. It's in between these 2 intervals. And then for x minus 3, it will be out here. So why is that a good thing? Because the point wherein this becomes 0 marks the change in signs. Just to illustrate what I mean by that one, take note, let's say we have a number line out here. Let's see, this is where 1 is, this is where 0 is, and this is where 2 is. So for x minus 1, again, the point wherein it becomes 0 is this point out here. But observe that on the left of that one, let's see, let's take 0 to be a test value. If we plug in 0 out here, we'll get negative 1. So we'll actually obtain a negative value out here. Negative. Let me just use a different color for this one. And then on the right of it, let's say if you use 2 as your test values, so this one will become equal to 1, and that will be a positive value. So as you can see, the point wherein this equation is equal to 0 marks the shift or the change in the signs of the given. So this means that all we need to do is just to test the values out here, and then the corresponding parts will adjust accordingly. For this first one, let's use the test value 0. For check at infinity to 1, use test. So using that one, as shown earlier, if we plug in 0 out here, we'll obtain a negative value out here, and the same goes if we use 0 out here, we'll obtain negative value out here. And then again, like illustrated earlier, these points mark the change in signs. So for the first row, we are sure that this one will be positive already. For the second row, we know that this one will still be negative since there is no change of sign out here. It still appears here. So the change in sign will occur out here. So getting the product out here, we just multiply these signs out here. So we'll have here negative times negative is positive, positive times negative is negative, and positive times positive is positive. And then lastly, before we end this one, take note that since we are dealing with equal to out here, it's best to shade these ones. So let me shade that one. That just means that in our solution set, we will include the value at x equals 1 and x equal to 3 in intervals. In case you didn't know, a hollow one means that a point is not included, and then a shaded one means that it is included. And then since our goal is less than or equal to 0, the equal to part corresponds to these points. The less than part corresponds to negative, which means this one out here. So we conclude that with this one, the answer for the given problem will be from x from 1 to 3. Or in interval notation, you can write it as x in the closed interval 1 to 3. And these two will be the answer for the given problem. So that's it for this part 2 of inequalities. So basically we went over 4 problems, and you might be asking, how about for higher degree? Let's say this one will be cube. Although we have an example earlier regarding that one, we were able to reduce it to a linear inequality. But in the case that we'll have this one, so let's see, we'll have another factor out here, x minus 2. The idea will still be the same. We will be needing to construct a table of values, but this time we'll probably have an extra column and an extra row out here before the product part. Okay, so for the next video, we'll be dealing with rational inequalities. If you may, please check out the Google form that is in the description or the link down below. It's just a simple form, just a quick one, probably just 3 questions. You can even just answer what you want, and just feedback on how you think I can better improve how I teach math concepts or study tips, what you want to see in next video, and in general how I can provide better content that is catered to your needs. And yeah, I hope you learned a lot from this video. That's it, and have a nice day.